in this video we are going to learn reflection of light by spherical mirror. So what is spherical mirror? So to understand what is spherical mirror exactly, first of all study the types of mirrors now. So let us start. Mirror is basically divided into two types, that is, one is plane mirror and the other one is, the other part is curved or spherical mirror. So in plane mirror we can see the plane mirror like this. So we already studied that. So the ray on this is a normal and the ray will come and it will reflect back. So this is angle of, this is incident ray and this is reflected ray. This is angle of incident and this is angle of reflection. But what about the curved mirror now? So again in the curved mirror we have two types basically. So let us learn that one by one now. That is concave and convex mirror. So what is the figure for that concave and convex mirror? So let us see that now. So for concave mirror we have a mirror like this. So see that this is the curved path, this is the curved in nature. So the outer part is a rough part, silvered, it means painted part. So this inward, inside, this is the reflecting part. Whereas in this convex, the inside part is silvered, the rough part. The outside part is the reflecting part. So why it is called a spherical mirror? Because this the mirror, the part mirror, this is the reflecting part, and here we have mirror, one more mirror. Here this is the reflecting part, but this mirror is a part of a sphere. For example, if I extend this, if it is not visible properly, let me use the one more more sketch pen. So that is, so if I extend this, so this makes a complete sphere. So here also, okay, so this particular part is nothing but this particular section is a part of spherical sphere. So that's why it's called a spherical mirror. So how the rays will come, how the rays will interact with this particular spherical mirrors. So let us study one by one now. So in this, basically to understand this properly, we should know some few basic definitions. Those are pole, aperture, center of curvature, radius of curvature, principal focus, and focal length, etc. So let us see one by one now. So let me point out the first point here. This is the pole. Pole, generally it is represented by P. So for this, here this is the pole. Okay, what is pole then? Pole is actually the midpoint of this particular aperture or the reflecting surface. So geometrical center is nothing but pole. Geometrical center means from here to here, whatever the length is, that particular center of this particular part is geometrical center, that is nothing but pole. So then what is aperture? Aperture is the area, the total area which is available for the reflection purpose. So this particular part, suppose here also we have this particular part. So this particular part is nothing but aperture. This point is pole and this particular point is aperture. You have to make the definition, you have to write the definitions. Later I am going to give the definitions in written. Okay, then now if I consider this complete thing is a sphere, so obviously we will be having a center for this. Here also we have a center, So this particular point is center of curvature. Okay, so this particular point is center of curvature. The center of the sphere is nothing but center of curvature. So we have done with the pole, we have done with the aperture, and we have done with the center of curvature. So then now we'll see the radius of curvature. Means the distance between center of curvature and the pole. This distance is radius of curvature. Here also, if I have a look at convex mirror, so this particular length, the distance between the pole and the center is radius of curvature. So hope you got this radius of curvature. Now we have to see what is principal focus. So principal focus means once the rays are going to strike the reflecting surface, then it is going to focus one particular point. So in this case, suppose in this plane, normal plane, so the ray is coming like this and it is reflecting back. Suppose if in this if the ray is coming like this and again it is to go back like this only. Okay, with respect to normal, if it is coming, it is to reflect back, because the angle of incidence and angle of reflection will be same in this case. So here the angle of incidence is I, here the angle of reflection is R. So we know that angle of I is equal to angle of R. But what about this here in the spherical? Whether the law will holds good or not, we'll see that now. So suppose if the rays are coming like this. So before that I'll draw a principal axis. So the principal axis is the line joining center of curvature and the pole is nothing but principal axis. Principal axis. So it's a simply line joining the center of curvature and the pole is nothing but principal axis. There is no particular distance for this, it can be infinite. So it's a line joining the center of curvature and the pole is nothing but principal axis. Now the rays will always should be parallel to this principal axis. So whatever the rays are coming, maybe it is from infinity, or if we keep some object here, so the rays always should travel parallel to this principal axis. Suppose now we'll consider few rays. So the ray will come here, so one more ray will come here like this. Okay, so one more ray, let us take this side. Okay, so this is coming like this. Now where this will this ray will go? The ray, since it is a concave, so the ray will converge at one particular point. We'll see that. So once this strikes, this will come back and meet here. So the ray will go like this. So what about this line? This line also will, after getting reflected, it is like coming like this. So what about this ray? So once it goes and strike the incident here, so this will also make a move like this. Okay, so this particular point is called as principal focus. We'll write that with a capital F. So we'll write this particular point as capital F. So here, so from this is center of curvature, this is pole, and this is principal focus. It means all the rays is going to converge and focus at one particular point, that is nothing but focus. So what about this here in convex? So again, if the rays are coming like this, now since it is a convex in nature, these rays are going to be diverge. So instead of converging, it is diverging like this. So the ray will diverge away. So how this particular ray will go at what? So from where it is going away, it appears to diverge from this particular point F. Again we have principal focus here. So this is appear to be coming from this particular point. Okay. Okay. So hope you got to know what is principal focus. This is also principal focus. Now we'll study about this detail about this further later, bit later. Now we'll see what is focal length, f. So from this particular point to this particular point, the distance between principal focus and the pole is nothing but focal length. Means once the ray is going to strike the surface, reflecting surface, here it is converging and here it is diverging, but it is appears to be diverged from this particular point f. So here also it is converging to the point f, capital F I mean. So the distance between capital F, I mean principal focus, and the pole is nothing but focal length. Why it is called as focal length? Because the rays are going to focus at this particular point. So always you have to measure the length from this particular point P. That will deal these things we are going to discuss in sign convention again, why we have to measure from the pole and all. Anyway, from this particular point P to F is nothing but small f, that is length. The distance from point P to F is focal length. So here also it is the same. So we discussed about the aperture, we finished, we are done with the principal focus, we are done with the pole, we have done with the center of curvature, we have done with the radius of curvature. So one more thing is paraxial rays. Paraxial rays means the rays which are parallel. So these rays are nothing but paraxial rays. The rays will always come in parallel to this principal axis. So those rays are nothing but paraxial rays. So if the figure is confusing, let me draw the bigger figure for you. So I just take concave mirror, bigger one. So this part is the silver plate, silver part, it means painted. So this inside is reflecting part. So you can easily remember, see here the concave. So this cave, you can remember that easily. Cave means the guhe, right? So you can enter the cave like this, it means this is the reflecting part. So let me draw the principal axis. So here, so if I construct a sphere, so I can have a center of curvature here. So let me call this as C. So exactly at the middle we have to draw the F, that is principal focus. So this is pole, from here to here the distance between center of curvature to the pole is R, and from here to here it is F, that is focal length. So P is pole, F is principal focus, C is center of curvature, R is radius of curvature, and F is the small f is the focal length. So this part, so let me draw this as M and M dash. So whatever the area it is available for the reflection, so from M to M dash, mirror M to M dash, the area available for the reflection, that area is aperture. So here also we can see aperture. So this particular part is aperture. So hope I have covered all the points. So we'll get the notes bit later, either printed or the written in the written form bit later. Now we'll see one more important thing. So I told you that the ray, once it strikes the surface, it is coming and falling here. But here we noticed in the plane mirror, the angle of incident and angle of reflection are same. Whether here in the curved nature, the curved surface, whether that law will hold good or not. But in the previous video, I shown that even the diffused reflection also will holds good the law. So what about here in this case? Even in this case, in both concave and convex, always the law of reflection will holds good. Let us see that now. Now suppose one ray is coming, and so coming, and it is going like this. Okay, so this will strike. So where to draw the normal now? So we know normal, it means perpendicular to this particular point, right? So how to draw the perpendicular or normal for the spherical surface? So it is very easy, that always draw a line joining the point on the sphere or the spherical surface and join it to the center of curvature. Okay, so this is your normal for the spherical surface. Always this is your normal. Suppose I want to take this point or this point or this point, anywhere, from anywhere, if you draw the line going towards the center, that will be normal. So if the light is coming and striking this spherical surface, reflecting part, so it is going to reflect back in this direction. Obviously this is now here, this is angle of incidence and this is angle of reflection. So both this I and R should be equal. So here also we saw that angle of incident and angle of reflection will be same, because here the angle between the normal and I is equal to angle between normal and R, that is reflecting. So when the plane on the plane, if the light is striking like this with respect to normal, it means again it will be reflecting back with the same. It means I is equal to R is equal to 0, because with respect to n normal, okay, not with respect to plane. So n and I are in the same line, it means I is 0, and again R is also 0, right, because it is going back in the same direction. So here also, if I want to get the I is equal to R is equal to 0, then the ray will pass through from which particular eye? So that is the important question. So if I make the ray to come in this particular line and fall here, and it will come back here, so I will be equal to R. Suppose I want I is equal to R is equal to 0, then the ray should obviously go like this or from here, okay, because this is a normal we have constructed. So again it will, once the ray will go like this, strike the surface, and again it will come back in the same direction. So here in this particular case, if the ray is going through the point C and touching the surface, and again it is reflecting back with the same line, and this particular incident ray will make angle 0 with respect to normal, and reflected ray also will be 0 with respect to normal. So this is the point. Let me add up one more point. You might get the question. Suppose if the ray is going like this, the straight ray, but after striking the surface, it is coming and striking, or coming and passing through this F. Now suppose if the ray is passing through the F and striking the surface, will it be straight like this? Yes, obviously. So now if the ray is going like this, okay, once you strike the surface, obviously it will go back like this. So again the angle of incidence, so this will be normal then. Now for this particular ray, this will be angle of incidence and this will be angle of reflection. Maybe the figure is not that exact, not ideal, but assume that this I and R are equal. So exactly in the actually happening with the same thing. In practice, in nature, we can observe the same thing, but here the figure is slight, maybe it appears to be bigger than this, but in reality I will be equal to R and R will be equal to I. So suppose the ray is passing through the focus and striking the surface, and it will go through the straight line which is parallel to the principal axis. And in the beginning I told you this particular point F is exactly at the center from this here to here. It means from here to here r is there, here to here f is there. It means f is r is equal to r by 2, or r is equal to 2 times f. See here, r is equal to 2 times f. It means f is equal to r by 2. So that derivation we will prove in the next video, and also we'll see the sign conventions in the next video. Thank you very much.